Welcome to this walkthrough tutorial to Bento. Bento is a new software of mine which is basically a noise box inspired by the Japanoise music scene. And this software is of course a standalone software, and it has also a handy tape recorder here. And it's quite peculiar, first off because it's very fat analog sound, and it features some kind of strange oscillators I have developed, which are basically simulating analog computers, differential equation solvers, which create a strange set of waveforms which are very unstable. And first of all, don't get scared by the interface. Even if it's in Japanese, you will learn to use it pretty easily and quickly. And by the way, always take a look at the signal path, because this is quite self-explaining. We have two different sound generators, which are this one and this one. And then we have a filter section for each signal path. And then a VCA with envelope and clocks for triggering the envelopes. And let's start from the blue section and let's hear some sound. By default, when you open the software, you have these presets here, and the first one is triggered, so you have a sound going on, but you can lower this to which are the main output volumes to just take care of one of the signal path at a time and understand the basic functions of the software. So we'll take the blue path here, and first off, let's recognize where the filter is, which is this one. This is a 24 dB low pass filter, but and here is the resonance, of course. But it has also some peculiar stuff here. For example, we have a couple of sections of saturation of the sound and distortion. And if you take a look at this is a feedback network that feeds back the sound back inside the filter, which is not the resonance, but it's a real feedback network, which can create very wild sound. So I will back at the filter later. We'll now take a look at the generator, which is the most peculiar part of the software. So we don't have classical interface controls of oscillators like frequency or phase. We have here amplitude. This is the only normal control you will find here. And then we have these four controls. In some ways, they react to frequency like this. But this is not a proper frequency value. Actually, this is the frequency of an impulse we are sending inside the network. And this one is the amplitude of this impulse. And what happens is that the impulse gets integrated and then integrated again and then feedback, and it creates an oscillating sound. This is the I was saying the amplitude of this impulse, but it's also the amplitude of the feedback network here. So Also, this control has some effects on the frequency, of overall frequency of the sound. It has positive and negative values. But take a look at these two controls here. These are made to create instability inside the generator. Actually, it's very easy to create some instabilities that will lead to noises, and this is a very huge difference between these generators and normal oscillators, analogous or digital oscillators. Also, take a look here. We have 3 different range selectors because we can use very tiny numbers to create a huge amount of variations in the sound. So let's see what happens when this control gets positive. Yeah, you're starting to have some noise. If you go negative, we're back to kind of stable sound. So in a negative way, this generator gets more stable, but this can be changed a little bit with this control. Of course, it's unpredictable. So as you can hear, it's quite unstable and it's quite difficult to predict exactly what the control will do. So you have to explore this machine. It's not easy to say what will happen, and this is the fun of it, of course. There are many possibilities of combinations between these controls to create very interesting sounds. And after this strange generator, the signal goes in 2 different paths. The first, of course, is the filter. And the filter, as I was saying, is a 24 dB per octave low-pass filter, which is kind of classic, of course. And then you have 2 stages of saturation and distortion, and then feedback channel here. So let's hear what happens with this mess. What happens? And we have some interesting controls here, which modulates the cutoff frequency of the filter. The first one is this, and if you look at the path of the sound, it's coming from the red generator. So we can use this generator here, which you can find here, to modulate the cutoff frequency or the amplitude of the pulse going inside the circuit here. So we have two different modulations caused by the other generator, and this is of course is reciprocal, because this signal goes here and modulates this amplitude here, or here and modulates the cutoff filter. As you can see, the signal of the modulation of the cutoff is rectified, so we have only a positive waveform to modulate the filter. This is done to avoid negative filter frequencies. And let's see what happened now. For example, we can try to, well, let's recall the first. Okay, this is the first preset, and let's take off the red path and use only the blue signal, and we can modulate now the filter with this oscillator here. And but away, of course, the generator is just identical to the blue path, and it has the very same instabilities that we use on the first one. So we can create very complex networks of sound that modulate and cross-modulate filters and generators, and instability is the key word of this machine. We have here two controls for after each filter, and these basically are a balance between the filtered sound and the pure sound without filter. So we can choose whether to have not filtered sound or filtered sound or something in between. Of course, this control creates some phase cancellation, which are kind of nice. So no filter, filter, and the same is here. And after the sound gets into the balance selector, it goes, the blue sound goes to this circuit that basically ring modulates with the red signal. So we can have a ring modulation here. That's true only for the blue generator. So of course, here we have the same pad with the red oscillator. And here the blue one. Now, we have also here an envelope generator with a clock function. And we have two clocks actually, and they are not related one each other, so they are independent. And the clock has two functions. This is normal and this is random clock. So you activate the clock by turning this clockwise. And this is the attack and this is the release. And once you trigger the clock, once it's on, here we generate some random controls which we can use to modulate the filter. And we can switch this on and have random clocks. You have the same thing here. So basically, this is the signal path is fully explained. Now, one interesting feature here is a tape recorder, and we can record our sound here. And we have first off a different kind of tapes, models. We have with different saturation and distortion and other characteristics which will affect the overall sound. And of course you can use it before recording. Once you have recorded the sound, these settings are bypassed, of course, because the sound has been recorded inside the buffer. You have here a tape simulation control or on or off, and then some flavors here, and then you have some tape saturation and some control on the level, which is not radical, but just that control that gives a little bit more punchy sound to the tape. And let's use the tape recorder, changing some presets. So first up, you want to change the length of the tape in seconds. So let's say 240 seconds. Press enter, and now we have 240 seconds to record. Let's press record now, and we can change some presets and listen what happens. Whenever you want some silence, you just select the John Cage preset. And there we have our tape recorded, and we can play it back from the point we like. For example, here or here. And of course, we can go here and keep recording something else, like now, of course, you can play it back or export it as an IF or WAV audio file, 24 bits, 44,100 kilohertz. And this is pretty much everything about Bento, which is a standalone software. And if you need to connect this software with your workstation, it's not a problem. You don't have to have plugin to connect it. It's also very simple. You just select here your virtual audio driver like this, and then you open your workstation, and then you select the very same output in your input of the workstation. Like, let's do a new project. here. Create one audio track, and then you set the preferences. And then you select the input device, the same black hole or virtual audio driver interface. You put this and this, and then you take. And then, of course, you can record whatever you want here. Take a look at the volumes. In reality, we are not distorting the sound, but you can lower this one a little bit just to be sure. And this is it. It's pretty easy to use and pretty straightforward, and it's designed for live performance and improvisation, maybe with analog equipment. It doesn't have audio inputs or MIDI keyboard input, but you can map everything with a MIDI controller, and of course you can also map some keyboard keys of your keyboard here. Of course, you can load and save presets, and then you can first, of course, explore some audio examples here. I hope you enjoy Bento, and you can download it from my website. The price is just 19.5 euros. It's very cheap, and it sounds huge and analog, and it's better funny software for everybody who is into drone and noise music, and also, of course, sound design, because this tool can create a huge amount of noises which can be useful for sound design. So thank you for being here, and I hope you like it. See you the next time. Bye.